Hello guys, in today's video I wanted to talk about the factory pattern and how you can apply this in Solidity and how you can optimize the gas for that. Just before diving it, so what is a factory pattern? If you're already familiar with design pattern, you may know already that, but basically it is a pattern in algorithm allowing you to have like a single contract that will be in charge, contract in Solidity, but object in other programming language, that will be in charge of deploying other contracts and having like different instance for that. So if we take just these few examples, we will have a logistic object, and we will have like different implementation based on how we want to handle this. And so either by having a truck or a ship here. And so in the case of the factory, this will be the one that will be in charge to create like a new truck or a new chip, depending on the implementation that we want to have. So if now we do like the kind of example inside like a more blockchain example, you can think of a pool that you will have for like a liquidity pool. And so basically each time that you want to create a new one, you're going to deploy a new pool with like two different devices. So like that could be like for USDC, BTC, or you can create a new one for like ETH, USDC, etc. And you can also like deploy like a new one with different type and strategies. So that's how factory pattern can be used and how you can see them. A generic approach would be like if you already used a different contract, programming language. Basically, the idea would be like to have a factory object where you instantiate, I would say, a new component. So here in that case, a child, but of course, like you can have like different kind of child implementation, but here it's just for example. And then your factory will track like all the different objects that have been created. The main issue with this approach is that each time that you're going to create a new object, basically you're going to redeploy the same bytecode for the child implementation. And so this would be like a huge concern because you will need to pay for the gas for everything. And so if each time that you're creating a new object, you need to kind of copy paste the bytecode, could we think about a better implementation and trying to dissociate like the bytecode, because it will be the same for all the different implementation contracts that you want to instantiate, and the data that will be specific to the one that you want to create. So if again I took an example, let's say that you have like a liquidity pool that will works the same for all the different like pair that you will have. And so instead of redeploying each time the new contract by having like the bytes code that will be copy paste for all of them, you can decide to deploy only once the bytecode logic that remain the same for all of them, but instantiate only the data on the specific contract in order like to reduce the cost. And that's the idea of like the minimal proxy contract. So basically the IP 1167 introduced the idea of having a minimal proxy pattern. So the idea would be like to use a clone contract, I would say, that will be in charge of having only one contract deployed for the bytecodes and another one that will be in charge only to the storage. So if we take a look at the implementation here, instead of, so we will still have like our two contracts. So one for the child and another one for the factory. And here the idea will be like on the constructor, we are going to deploy one time the child implementation. And as you can see in the create child function, instead of using the new operation, we're simply going to clone the contract and then initialize it by using the data that we want to have on this contract. So under the hood, what's happening is on the constructor, we're deploying effectively a new contract that will have like this on address. And here that will be immutable because we don't want this implementation to be changed over time. And then each time that we're going to create a new child, we're going to use this implementation as a reference and generate like a proxy pattern that will leverage the existing implementation, but instead of storing all the different code that we will have here, it will only store like the storage variable that are needed in order to do some operation. And so as you can see here, we need to initialize the proxy pattern, where we are going to define like the different variables that we need. So under the hood again, like we are leveraging the delegate call that is currently used in the proxy pattern by calling directly the reference that needs, so here the implementation, without storing them. So this is quite useful because here it reduced like the gas cost that we need. I've run like some gas metric here. We have like some optimization process, but the thing is also it will be like really important to have it, especially if you have like an implementation that is pretty big, like you have like a complex one that maybe require like different different interactions. So that's where it can be interesting. And also like this could be interesting in the case where you have like a complex factory that need to where you need to instantiate like different a lot of different implementation. You will run into like some issue, some limitation on the bytes code, because a contract right now are limited to 24 kilobytes at the moment. Maybe not in the future, but right now this is the case. So you cannot have like thousands of different child implementation, and so that's where the clone one can be useful. Hope you learned something during this video. Just wanted to highlight how you can optimize using a proxy pattern like the factory pattern. Feel free to follow me like on Medium if you are kind of interested in that kind of article. And hope to see you in next video. Bye-bye.